Hi all, I'm Madam Kong. Welcome to my virtual class. The purpose of this video is to revise Organic Chemistry SK025 by using set PSPM 2017-2018. This is the question 2 of this set paper, and then it involves chapter 5 hydrocarbon. Okay, let's analyze the question. Reaction of reactive bromine radical with compound A form a monobrominated product B, while compound C react with bromine gas in dichloromethane to produce compound D. So given compound A, okay, so the first question have to draw the structure of compound A, third butyl hexene. So 1, 2, 3, 4, 5, 6 hexene, and then third butyl, meaning that there are 3 CH3 here. Okay, for compound C, okay, 1, 2, 3, 4, 5, 6 hexene. So the scene is at C3, so carbon-carbon double bond over here, and then there is a third methyl as well. Okay, so B, identify which of the compound in 2A exhibits chirality. So let's check. Okay, first of all, right, you must remember the rules and regulation to exhibit chirality. First must have chiral carbon and then attached to 4 different groups. So no, H3, H2 no. Okay, check this one. Yes, 1 group, 2 group, 3 group, 4 groups. So for this compound, there is a chiral carbon. So attached to 4 different groups. For this one, no. Because one of the regulation must be sp3. So this one not sp3, cannot. These 2 carbon cannot. So H2, H3, H2, H3, there is no, there are no 4 different groups. So for compound C, there is no chiral carbon. So compound A, the answer is, and then you have to draw a pair of enantiomer. So you must draw in 3-dimensional. Even though the question didn't mention 3-dimensional formula, you also must draw in 3-dimensional formula. Okay, so reflect. Okay, there is a mirror here, and then must label enantiomer. Okay, name the type of reaction involved in the formation of B and D. So B. Okay, B, there is a bromine radical. So free radical substitution. Bromine gas in dichloromethane. Okay. Also can involve free radical substitution reaction. Okay, draw the structure B and D. For compound B undergo free radical substitution. That's why the Br free radical was substituted to the C3. And then compound D actually is electrophilic addition because of bromine in inert solvent. That's why there are 2 atom bromine, okay, attached to C3 and C4. Next, by using curved arrow, show the initiation and propagation step for the formation of B. So for B, so first must start with initiation step. So the bromine molecule, okay, undergo homolytic cleavage with the aid of UV light and then form 2 bromo free radical. And then the bromo free radical, okay, we'll try to propagate the H and the C bond, so it will form the free radical of hydrogen. The combination of these 2 will form the HBr, and then this C free radical will form the structure like this. And then this free alkyl free radical, right, will continue. Okay, so the bromine molecule will undergo free radical again. So the bromine free radical will attach to the CO here to form this compound haloalkane, and then bromine free radical is formed. Oh, one more question. Have to identify a chemical test to differentiate compound C and compound A. Compound C is an alkene group, and then compound A is an alkane group. So we can using Bayer test. So the condition is using KMnO4 in basic solution. The condition is cold, so it will form diol. Purple color of KMnO4 is decolorized, and a brown precipitate is formed for alkene. Alkane, no observable change, so you have to mention the observation of the purple color remain unchanged. Always remember the rules and regulation to answer the question related with chemical test. First, give the test of the name test, reagent, condition, equation 1, observation 1, equation 2, observation 2. For this question, there is another alternative answer. by using bromine in dichloromethane. So for compound C, okay, it will get two bromo. Electrophilic addition is happen. So bromine atom is substituted. So reddish brown color of bromine solution decolorized. And then for this one, no observable change. So the reddish brown color of bromine remain unchanged. For the observation, always remember you must tell me the original color of the solution change to white color. Okay, so purple color of KMnO4 remain unchanged. Purple color of KMnO4 is decolorized and brown precipitate is formed, something like that. Okay. Next question 3. There are two parts, part A, part B, and then each part they have their own sub question. Treatment of 2-bromo-2-methylbutane with water, yield compound E. So you must know how to draw 2-bromo-2-methylbutane. Okay, right, with water from E, and then the dehydration of E give compound F and G. So dehydration, so from here I know methane, this is haloalkane with water, and then will from the bromine will be substituted with the OH from alcohol, and then from alcohol, so it's dehydration of alcohol give two compound. This is alkene. Why there are two? Because the major and minor product. So state the reagent and reaction condition used in the dehydration of E. So for dehydration of alcohol, right, we need to use concentrated H2SO4, reflux or heat. Okay, this is another answer. And then draw the answer formula of compound EFG. The 2-bromo will substituted with OH group. So this is 2, okay. The answer is 2-methyl, 2-butanol. So from the 2-methyl, 2-butanol, so I can form the double bond over here. So this is the answer of this. I can form the double bond over here. So this is the answer. So F and G can be interchanged. Now among these two, which one is the major product? So for sure it's this one, because if you make a box over here, so 1 methyl group, 2 alkyl group, 3 alkyl group. If you make the box over here, 1, 2, there are only 2 methyl alkyl group. So explain your answer, because based on Sagev rules, the highly substituted with the alkyl group of the carbon-carbon bond is the major product. Always remember how to define Sagev rules. If you know how to define Sagev rule, then you will know the reason why this is the major product. Okay, try to recall the definition of Sagev rules. Is in an elimination reaction, the major product is the alkene with greater number of alkyl group bonded to the carbon-carbon double bond. So for example, this one, there are 3 alkyl group. This one, there are 2 alkyl group. That's why this is the major product. Okay, next we need to continue draw the mechanism for the formation of E. Again, this question actually same as 2018-2019, meaning that 2017-2018 this question came out already, and then 2018-2019 came out again. So this is tertiary haloalkane. So tertiary haloalkane will undergo unimolecular nucleophilic substitution SN1. So step 1, formation of carbocation. Okay, so this will form the bromine negative anion, and then here will form the carbocation. So tertiary carbocation is formed due to the hydrolytic cleavage of CCl bond. Then step 2 and step 3 is the attacking of nucleophile. The weak nucleophile such as water attack the carbocation to form the product. This is the protonator of alcohol, and then so water will try to take back the H to regain the H3O plus and then form the alcohol. So this is the product of this reaction. Okay, part B, 3-phenylpentane react with acidified water to yield 2 compound H and J. You must know how to draw the 3-phenylpentane. Okay, phenylpentane 1, 2, 3, 4, 5. Okay, since there is no mention the position of the pentane, means C1 pentane, And then position number 3, there is a phenyl. So to use compound H when react with acidified water, meaning this is electrophilic addition. So OH is added to this C2. Okay, because the formation of H is follow Markovnikov rules. So here this is the compound H which follow Markovnikov rules. OH is added to here, H added to here, because according to Markovnikov rules, the electrophile or the hydrogen atom is added to the C with greater number of H. So here's 2H, here 1H. So that's why H over here, OH over here. Where else the carbocation ion rearrangement? Okay, if I form the carbocation ion over here, yes, I can undergo 1,2 hydride shift to here and then form the tertiary carbocation ion. When form the tertiary carbocation ion, then my OH will substitute to the C3. So this is the compound J. Okay, clear? Okay, number 2, suggest the product form when compound H. So this is compound H is oxidized. So compound H is an alcohol. Once it's oxidized, it will form secondary alcohol. That's why it will form ketone. So this is the answer, 3-phenyl-2-pentanone. Okay, 3. What will happen when compound J? Where's compound J? This is the compound J. Here, this is the compound J. Oxidize. So this is tertiary alcohol. So no reaction happen, no oxidative change. So purple color of CmNO4 remain unchanged. Why? Because for tertiary alcohol, right, there is no benzylic hydrogen. So it will not continue to oxidize with strong oxidizing agent for tertiary alcohol. Next, question 4. For question 4, there are 2 parts as well. So part A, part B. Part B, okay, this is the question. I always say simple question. Okay, question A, 3-methyl-2-phenyl-2-butanol can be prepared from the reaction between carbonyl compound and Grignard reagent. So draw the structure and state the class of this alcohol. So you just draw, okay, butanol 1, 2, 3, 4. And then 2 butanol, so OH over here, and then 2 there is a phenyl group, and then 3 methyl. So this is a structure for 3-methyl-2-phenyl-2-butanol. And then the class of this alcohol is tertiary, 1 alkyl group, 2 alkyl group, 3 alkyl group. So it's a tertiary alcohol. And then draw all the possible pairs of carbonyl compound and Grignard reagent that can be used to form 3-methyl-2-phenyl-2-butanol. Actually, this one you have to be clear how to break the bond. Then you okay. So I'm using different color. So this is the orange color. I break over here. So this is the alcohol. This part is the alcohol. Okay. So this part from the alcohol. So it's from ketone. You just make sure the OH actually is originated from double bond O, ketone. And then this is from the Grignard reagent. So the Grignard reagent always attached with MgBr. Okay, next is for the blue color. I break over here. I break over here. So this part, the whole part is from the ketone part. And then the CH3 MgBr. This is the Grignard reagent. I also can break through over here. And then this part is the Grignard reagent. So CH3, CH, MgBr, CH3. And then this part is from the ketone part. Okay, get it? So have to show all, because the question wants all the possible pairs of carbonyl compound. Okay. For this question, it started from 1 bromopentane. So 1, 2, 3, 4, 5. Okay, 5. So I start from here. Suppose 1 bromopentane. So how can it become a nitrile compound? So what is the reagent K? So the reagent K is, you replace with KCN, NaCN, or Cn negative. So you just write down KCN. And then from KCN, hydrolyzed, it will become carboxylic acid. So the number of carbon actually still stick to the same. 1, 2, 3, 4, 5, 6. And then becomes COH. Just check. L. 1, 2, 3, 4, 5, 6. The 6 becomes COH. Okay. And then L is carboxylic acid. This reagent is alcohol, meaning that esterification is happened. So M is an ester. So I will take the H from the alcohol and then OH from the carboxylic acid and then form this compound. So the cyclohexane is attached over here. The O cyclohexane. Okay, so the phenoxide actually here, not phenoxide, cyclohexanoside. Okay, attached with this carboxylic acid part. Okay, next go for N. Okay, actually it's nucleophilic substitution. So the Br is substituted by OH. So this is the compound. And then PCC, because it's a primary alcohol, we need to use PCC in order to form a propana. So this is pentana. And then if I'm using strong oxidizing agent, I straight away will form the pentanoic acid. From pentanoic acid react with NaOH actually is neutralization process. So you form a salt. So O negative and Na plus. Is it simple for this question? If you're able to answer to the L, M, N, P, Q, R, and this, total 7 marks. Okay, next question 6. Hexane C4H16 can exist in many isomeric form. Draw all structure isomer of hexane. After we draw all isomer, we have to determine whether there is any chiral isomer and explain your answer for part A. And then question B is question related with deduce a structure. Okay, for S until S to W and give the equation. C6H14, so there are straight line with one branch at C2, one branch at C3, and then two branch at C2 and C3, and then two branch at C2, C2. So total there are 1, 2, 3, 4, 5 isomers for C6H14. But among these 5, there is no chiral isomer because we check. Yes, all of them are sp3 carbon, but there are no 4 different groups attached to it. H3, H2, 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 H3. And then this one, CH3, CH3, same. And then for this one, CH3, CH2, CH3, CH2, same. Here, H3, CH3, CH3. Here, CH3, CH3. Here, CH3, CH3, CH3. All of the C will attach to the same atom or same group. So no chiral center that hold 4 different group of atoms. Okay, for A2, name the type of bond cleavage when hexane undergo halogenation in the presence of light, and then write an equation to show the bond cleavage. Okay, look at CH. So the bond is composed of 2 electrons. One is given to hydrogen, another one is given to C. So the number of electrons given to each atom is the same, one electron, so it's homolytic cleavage. So after the hydrogen free radical join with the bromine free radical, it will form HBr, and then the carbon free radical here will form this compound. Next. Okay, hydrocarbon SC8H8 react with hydrogen in the presence of platinum catalyst to UT. Okay, hydrogenation is happened. This one is an alkene. So this one is an alkane. Okay, C8H8. The number of C and number of H, the ratio is 1 to 1. So definitely this is a benzene compound. So yes, cyclohexane with 2C form double bond. So this is S. 1, 2, 3, 4, 5, 6, 7, 8. Yes, C8H8. And then undergo hydrogenation for the step 2. Okay, and then compound T is U. So this is T. So hydrogen is added over here, hydrogen is added over here. So T is formed. And then compound U is formed when T is heated. So this T heated with Cavanol form, followed by hydrolysis. So this is oxidation. Okay, so this C is attached with hydrogen atom, so it straight away will form benzoic acid. So U is formed, followed by hydrolysis. Okay, the reaction of S with hydrogen bromide. So HBr is added, so electrophilic addition. So you have to follow Markovnikov rule. H added to the C with greater number of hydrogen. So here is Br. Okay, give V. So this is V. Whereas ozonolysis of S, so you have to break the bond and then produce W and methanol. Yes, this is the methanol. CH2 double bond O. And then W here double bond O. Okay, so aldehyde is formed. So this is W. After we success to get the compound STUVW, then we have to draw all the structure and give the name of the reaction for the conversion of S to T. From S to T, okay, name of the reaction. So this is name of the reaction, not type of the reaction. So the answer is hydrogenation. If the question asks type of the reaction, then it's electrophilic addition. But the question asks give the name of the reaction. Okay, and then write all the chemical equation involved. So according to the 1, 2, 3, 4, so here is the answer for 1, 2, 3, 4. Okay, again for this one, oxidizing agent, if you're able to remember the 1 Roman KMnO4 hydroxide heat, 2 Roman H3O plus, you stick to it. If you cannot, you just remember the simple version. KMnO4, comma, H plus, heat. Next. Question 7. Aromatic ring. So part A is related with benzene ring. Part B, Grignard reagent, bromocyclopentane. So this part is related with haloalkane. Aromatic ring is less reactive towards chlorine than alkene. By using suitable equation, explain this statement. So you explain what happened to benzene. Benzene undergo electrophilic aromatic substitution reaction with chlorine gas masked in the presence of Lewis acid, so to produce chlorobenzene. After you explain, you show the equation. Must with catalyst out. Without catalyst, nothing happen. And alkene undergo electrophilic addition, so with chlorine gas to produce haloalkene without Lewis acid. So this is chlorine gas. Okay, so it will produce CH2, CH2, Cl, Cl. Actually, then you have to re-explain again about the aromatic ring has delocalized electron, which stabilize the ring. So it is less susceptible towards electrophilic attack. Thus, a Lewis acid is required to complete the reaction. So the Lewis acid refers to iron chloride. Next question, outlines a synthetic pathway from benzene to benzyl amine. So sure the reaction started with benzene ring, and then this is the craft alkylation. So the alkyl, the CH3 group is attached, and then undergo free radical substitution. So bromomethyl is formed, and then this is haloalkane. So this haloalkane undergo nucleophilic substitution, then ammonia group, so amine group is substituted over here. Then benzyl amine is formed. Okay, for second part, the part B about the haloalkene. Grignard reagent is a versatile tool in synthetic organic chemistry using bromocyclopentane. So this is bromocyclopentane as a starting material. Show how a Grignard reagent X is formed. Actually, when haloalkene reacts with magnesium in dry ether, then it will form Grignard reagent. So by using this Grignard reagent, it reacts with water. This is react with water to produce alkane. So compound 1 is an alkane. Okay. While treatment in carbon dioxide followed by hydrolysis, carbon dioxide followed by hydrolysis. So when Grignard reagent with CO2, right, carboxylic acid will be formed. And then 3-methyl-2-butanol. So this is a 3-methyl-2-butanol react with X. So here we form the tertiary alcohol. 1 alkyl group, 2 alkyl, 3 alkyl, tertiary alcohol, AA. So draw the structural formula for Y, Z, and AA, and write the chemical equation. So actually, it's easier for you to use the Y, Z, AA after you write down the equation. If you start with write the equation, don't forget you have to restate again what is compound Y, what is compound Z, and what is compound AA. Okay, this is the way 1 Roman, 2 Roman to write out the reagent. Okay, next. So this is question number 8. So 8A is related with amine, B is related with amino acid, and then C is related with polymer. So a group of students runs one simple experiment to distinguish 3 different classes of aliphatic amine and aniline. So BB, CC, DD, primary, secondary, and tertiary. Again, I use different color. BB is referred to primary, CC is referred to secondary, so your orange color. DD, blue color, is referred to tertiary aliphatic amine, respectively. So by using specific example of BB, CC, DD, so this is open question, so you can give any amine that with primary, secondary, and tertiary amine. Suggest a chemical test to differentiate them. So I will try to use the simplest one. So this is my BB with make sure that the number of carbon that you use for BB, CC, DD is the same. So for this one, I'm using propane amine. Okay, and then this is using N-methane ethene. So this one using N-dimethyl methane. Okay, so refer primary, secondary, tertiary, and then this is aniline. It's an aromatic aniline, aromatic amine. So there are 2 common tests we can use to differentiate the different class of amine. First is Hengbus, another one is nitrous acid. Since the question just suggests a chemical test to differentiate them, so you suggest. So for method 1, you suggest Hengbus test, and then some of you maybe think you have to write down the equation, but it's okay. After you write down the equation, right, you make sure you explain the observation. So for BB primary, right, addition of benzyl sulfonyl chloride in excess KOH, so clear solution. After that, continue with the addition of HCl, then white precipitate is formed. For secondary, okay, benzyl sulfuride chloride in excess KOH is added, then white precipitate is formed. Then followed by HCl, then white precipitate reform again, remain. So primary, clear, white precipitate. Secondary, white precipitate, white precipitate. How about tertiary? A clear solution is formed when benzene sulfonyl chloride in excess KOH is added, followed by addition of HCl, meaning that both clear. If for method 2 nitrous acid, right, the reagent is dilute hydrochloric acid and sodium nitrate at temperature 0 to 5 degrees Celsius. So for primary amine, it will form gas bubbles because due to the nitrogen. Okay. And then yellow oil is formed for secondary amine. Tertiary is a clear solution is remain. Okay. Okay, next we need to state the observation for 8AI and 8A2. So 8A1, we discussed about the nitrous and Hengbus test. And then 8A2, we need to differentiate between aliphatic amine and aniline. So we can use BB, CC, or DD to compare with aniline because 3 of them considered as aliphatic amine. Okay, so we can directly use bromine water, Br2 aqueous or Br2 common H2O to differentiate the aliphatic and aromatic amine because for the aromatic amine, aniline, it can form 2,4,6 tribromoaniline and then it will show the white precipitate. But for all the aliphatic amine, no white precipitate form. Okay, next question. Arrange BB, CC, and aniline in order of increasing basicity. 1, 2, 3. Explain your answer. So in this case, aniline has the lowest basicity. So weaker base compared to BB and CC. And then BB and CC is the strongest one. Why? Because CC is secondary amine, there are 2 alkyl group. BB is the primary amine, there is only 1 alkyl group. So the alkyl group actually is the electron donating group, which increase the electron density of nitrogen. So CC more basic than BB because CC has more alkyl group than BB. Aniline is a weaker base than BB and CC because due to the benzene ring, okay, the delocalize of electron in the benzene ring, which will destabilize the positive charge on nitrogen atom. Make the lone pair electron on nitrogen atom less readily to accept proton. If it not accept the proton, right, mean it won't form the hydroxide, so become less basic. Amino acid. Okay, this one simple question. Given this is the amino acid valine 5.96, draw the structure of valine as Pi. Pi means neutral. Okay, means that Zitron ion, it will form the Zitron ion. So the O will become a COOH negative, NH3 plus. If in acidic, right, means acid will react with base, so the amine group will form NH3 plus. Okay, this is basic condition. Basic condition, it will react with the carboxylic acid, so it will become the carboxide, COO negative. So vanillin react with 2,2-dimethylpropanol is an alcohol. So when alcohol react with the carboxylic acid, right, actually is esterification happen in the presence of acid catalyst. So acid catalyst can react with the amine side, which is neutralization process. So to you compound EE. So this is the compound EE. Let's go for the last question for this set of PSPM. Polymer can be prepared either by condensation or addition polymerization. Give one example of synthetic polymer for each type of polymerization. So meaning that I need to give an example for condensation, one example for addition. By using your choice, just condensation, state the respective monomer. So in this case, okay, addition polymerization we've learned for, you just need to give one, polyethylene, polyvinyl chloride, or polystyrene, and then state the monomer. And then, okay, no need, because just one example. Okay, you need to state the monomer for condensation polymerization. So Kevlar, nylon 66, so these are the monomer for each of the condensation polymerization. Here, I will recommend you all to organic companion ebook slider, because I already do the summary. For example, addition polymerization, in our syllabus there are 4, and then these are the monomer for each of the polymer, and then how to write the equation to form the polymer, and then what is the repeating unit for each polymer, and then the function of each polymer. So here is the condensation. There are 2, one is polyamide and another one is polyester. So we learn 3 in polyamide and learn 2 in polyester. So polyester are terylene and dacron, polyamide are nylon 66, nylon 6, and Kevlar. Okay, that's all for today. Thank you.